here, thought I'd make another video explaining some of the gray area items a bit more in detail for you. I'll be basing this video on questions I've received in the comments section. Well, if you didn't watch my first video of the waste oil stove here, I'd kind of recommend it. You'd probably have a little better understanding on where this one's going then. And where I'm going to start on this video is going into more detail on that oil feed system. Several of these things I'm going to show you, you probably aren't going to utilize on your build, so I'll try to keep them brief. Because of the oil tanks being one floor up, it will actually make pressure in the system. The gauge I have on the back here actually tells me if there is some oil in the tanks and roughly how much. Ideally, a 5-pound gauge would be perfect. Of course, you know how you use whatever you have laying around. And of course, the oil filter will catch any small particles that come down the line. The biggest reason for the oil filter is a slow speed valve if you're running a dual valve system. Eventually, you'll get a bunch of fine debris in the valve and it stops it from flowing, and if you're at idle, you're going to have a flame out when it goes on to high. That's not good. If the valve does get partially plugged, of course, you just wank it open and close it again, and yeah, the stuff gets by it and you're good for a while again, but that's going to be the problem you run into. Now, I know on my last video you've seen the pop machine shields that I had on here. You want to keep all the oil flow stuff here as consistent on temperature as possible, and then you don't have to mess with adjusting it all the time. It stays a lot more stable. One more thing I know I didn't show you on my last video is these tabs here for to hold all the hardware here mount underneath the stove. Now these are going to get hot, and I have pieces of heater hose on here, and also that keeps the heat from the stove transferring into the oil line, which would really drastically change the flow as the thing would warm up more. Now, let's go into a little more detail on this sediment bulb here. Now, instead of a gasket on there, I just threw an O-ring in the slot here. That works real good. And then, for that fitting, this is 1/4-inch pipe thread here. I drilled that hole a little bit, that hole, and then I got a 1/4-inch pipe tap and put that in there, and then threaded this fitting into that for the end. The copper tube that comes up here, this is 1/8-inch copper tube that comes out of there that I just soldered onto that fitting there. Now, something I want to show you guys that don't have any water in your shop and you don't heat it at all and you get out there and it's really cold. Originally, I did have, this is a 1/4-inch drill bit here. I did have a 1/4-inch copper tube going around right here for the feeder. Now, if it's a lot colder in your shop, that would be an idea for you guys. And the other thing is, when I first built the stove years back, I did have just a 1/4-inch line coming right out of here that I siliconed in the base here, and then a U in that to drip down here. And to show you, this is your 1/8-inch drill bit right here, and that would be 1/8-inch tubing that I have on there now. And the actual inside hole of that tubing is probably like 3/32, somewhere in that area, I would guess. So that gives you an idea how stingy this thing is on fuel. I know a lot of you are wondering how much oil does this use every day. It's one that's really tough for me to answer because there's so many variables that come into play on that. On how well the building would be insulated, how much the overhead doors would be open, what temperature are you bringing the building up from. There's a lot of variables, but basically, to give you an idea here, I'd guess roughly 2 to 3 gallons in an 8-hour day, minus 10 out, would maybe give you some kind of an idea. And yeah, it's going to be cycling from the idle to high speed with that temp. Now, what I have here is a pipe plug, which you can remove. And then I have a drill with a homemade drill bit. By the way, it's 5/16 if you'd like to know that, and then maybe once a month I'll run that down there and then clean any carbon out. And in case any of you are wondering, you can build one of these stoves without this heat shield. Just run that 1/4-inch pipe in. But the bad thing is then you're going to be cleaning that pipe out quite often. Okay, that's it for the oil feed system. Let's move on to the air system here. I'll give you some details here. I got this ready. I'm going to pull this off and kind of show you a little more details here. This is that muffler that I told you about that I had in the system. Do you need that? No, it's just nice. Now I've turned the smog pump on, and I'm going to let you hear how loud this is without the muffler on it. You can hear the pulsing from the vane pump. And for this muffler, that pipe is a little longer than I told a few of you folks. It's been years since I built this. And it actually does stick in the stove, maybe 7 inches or so. So I thought I better revise that one for you. And it just sets in here. Don't blow anything into the stove at all. All it does is blow cold air into this heat shield tube here. Now, one thing I wasn't very clear on my last video was where the air line comes in here from the smog pump. Now, some of you were asking, how does the air get into the stove? And I didn't really have that in the shot, so I'm going to get into great detail on that here in a moment. But I just wanted to show you, this is where it comes in, and then you go up to this next T, and you can see this is where it goes in the stove right here. But where I'm on this valve here yet, for the muffler, for that cooler, I wanted to explain to you, the smog pump makes more air than really what you need. And usually, I got the valve open about so far when the stove is running. Now I'm kind of doing this backwards from what you would think. Instead of restricting the air that's going into the stove, I am allowing more to escape with this blow-off valve here. As you can fine-tune the feed on the burner with this then by varying this a little bit either way to get the best lane possible. It's one of the adjustments. I'm going to show you a few more in a little bit here. Okay, on the back side, you can see where that smog pump pipe comes in. And this T here, where it goes into the stove, actually right here, I drilled and tapped it with a 1/4-inch pipe tap way in. And you can see, you can't see any of the threads right here. That's because I got this run in all the way. But I'm using this for support for this whole apparatus here. Now technically, you could just drill a hole, run a pipe in there, and tack weld it and you'd be fine. Now I'll show you what I got inside that you cannot see. And right inside the stove, I have a coupler in there for 1/4-inch coupler, and then your 1/4-inch fitting that goes to your copper 1/4-inch pipe. And it's crimp, one of the little ring fittings there. And of course, once all together, that's what it would look like inside the stove where you can't see it. And where that copper tubing, then where that eventually ends up here, it's underneath this plate right here. And the fitting in that would be right here. And of course there's kind of like a big U in it, and then it works its way to the burner and at the angle so you can get the swirl. And I got to tell you folks, a lot of questions have been asked on the mystery gauge here. What that is it's a capillary tube gauge. I got the X coil wound up behind here. But this is a fascia panel, and I just got the probe laying behind this. Yeah, I don't know if you ever put one of these on yours. I'll keep it brief here. But what I like to see when I come in is right around the 260 mark on the gauge. As the building warms up more, the gauge keeps coming down more and more as it's cycling. It can even get down to 140 when a stove after the building's warmed up. Now, if I come in from outside and I see the needle way over here by the 320, I know it's going to kick the high limit on the chimney where it'll be over 250 degrees. So then what I'll do is I'll cut the oil flow back just a tad. I took the burner right out so I could show you folks this here a little better where this copper line goes in. Remember, this is 1/4-inch outside diameter copper, and it goes through that hole right there and into the burner, oh, maybe an inch or so. And that's all there is to it. Once you get your unit up and going, you can even fine-tune by tweaking that end of that a little bit to get your ideal burn. Now you can see that hole in the deck there, and that's what that 3/8 steel pipe on the burner sets in. And there's your copper line, and you can see that other 3/8 steel pipe that sticks into the burner. Now if you come on the outside here, you can see where I have that all welded all the way around. And what the deal is with that is that also aids in the vortex for the flame to spin it. Once the flame gets going more, that does pull a little more air through there. Makes a little bit of difference, just a little more of the icing on the cake. One other note on this, if you just use the pipe fittings, they're going to want to turn on you. So this I popped a set screw in. You could do the same thing with a roll pin. And of course that 3/8 pipe, you can see where it goes through the floor there now. And if that burner would ever fill up with oil, something would go wrong, that's, like I said in the last video, where it would end up in the tray down here. Now another little thought for you. With that pipe, the way I have that mounted, the burner can even be running and you can fine tune it with a pry bar. You can move it to the left, to the right while it's running. And that uses that pipe for a swivel, so you can even tweak the flame a little more that way if need be. Once you get it figured out, just put the burner back in the same way every time you clean it. Now I purposely left that heat shield off the dripper so you folks could see what it looks like without that. And you can see right on the dripper I have that one hole punch there. That's for where my little wing nut thing holds the heat shield on. I like to have everything serviceable with no tools needed. And that'll give you an idea roughly of the height that it sits at here. So you know we have it apart. Oh, and another note for you folks here that I can tell you. You can run it, of course, without that heat shield on there. But what the main purpose is where that drips out of there, what happens is if you don't have that heat shield on, it can be burning right as that oil comes out of that tip there. That way, the oil's got to get down into the burner before it ignites. It makes a lot better burn, you could say, and once again, more efficient. And that's what it looks like with that heat shield on and no burner in. And you see the little wing nut? That's what holds it on. You just take your thumb and pop that off of there. That heat shield, it's about due for a new one. She's getting a little hammered. But then again, so is that burner. The burner's been for years. And as you can see, I had to put a little stainless patch on it a while back and do a little more welding on it. Hey tubers, I don't mean to make this look intimidating and that. Let me give you some more pointers here to make it a little more user-friendly for your build and hopefully save you some more time here. Now, some of you don't want to mess with the smog pump. Actually, for some time when I first built this, I used an air compressor, so I thought I'd tell you that. And I did do a lot of different burner designs. I made some out of tin at first. Yeah, they wouldn't last very long, but then you kind of know where you're going. Now you can vary the burner height and width. This is actually what I found works the best, but you can definitely go smaller if you wish. The only thing, I think this is the most efficient and the best burn for design. The other ones, though, you go a different size, they'll work too. So don't be overly nervous to experiment a little bit off of what I have here. Now, one more thing I'd like to touch base with you on here. Let's try to keep that wiring a little more simple for you folks here. So I kind of sketched this up here. Anyway, what we have here, I have 12-volt power supply. Everything is wired in a series here. And for the thermostat, you got to have the red and the white wires. Them are the ones you're going to use on that. Just so you know, your average thermostat, they don't want you to exceed 1 amp. They do have a relay inside of them. Read your enclosed sheet. It'll tell you if you are sufficient or not on that. Also, the new thermostats now, instead of having an anticipator, they have what they call cycles per hour you can set up. So I thought I'd tell you that too. Now, here's the one area. Get a solenoid that draws less than 1 amp. Otherwise, you're going to have to put a relay in the circuit. Now, I put down 12 volt on here. Now, technically, this stuff could be hooked to a 24 volt AC power supply if that would maybe be a better option for this solenoid. I have no idea what is out there for this solenoid. If any of you people watching this video found something that fits the ticket, maybe type something in on comments. We'll tell the other tubers about it that watch my channel here. And then, of course, a chimney safety switch and a stove safety switch would be a good idea too. But anyway, this is all wired in a series circuit. No lights or nothing. Let's keep it simple for you folks. Maybe if you want to make yours fully automatic, this would be a simpler option here for you instead of my over-engineered one that I made up here. Well, I'd start the stove up too and give YouTubers a shot of some of the stuff that I didn't shoot with the stove actually running last time. And here you can see how much oil's going in it. And we're going to come around to the side here where I concentrate the flame to lick on. And there's my laser gun right there. And it's about 10 below out today. This has been running for maybe 20 minutes. And she's going pretty good already. And these style stoves, they control the air in instead of the air out. This would be with the damper fully closed for air in. And that's fully open. And you can see how that affects the flame. Usually I just leave it right in about midsection and never touch it when I start it. We've been running for an hour and a half now. Unit's just starting to cycle. Here's where we're at. We come over on the side. Well, I hope this gives you a little better understanding on the operation of the oil stove here. Anyway, I got some more projects coming up that I'm going to show you. I got a lot of one-of-a-kind stuff that I build and design here, and I'd like to share that with you in the future. If you'd like to subscribe, feel free to do so. Click the like button. I always appreciate that. And anyway, yeah, I hope this makes your project go a lot smoother. If you got any questions or comments, put them in the section and I'll get back to you. Well, anyway, I'd like to thank you for your time and watching my video. Take care. Bye-bye. Preheat. I like that kind.